Dear students, I am Pratima. I welcome you all to this video. Today we'll discuss class 11, chapter 8, Binomial Theorem. We'll go for concept, then we'll go for exercise 8.1. So welcome. So we are starting Binomial Theorem, your class 11, chapter 8. The meaning of binomial is two terms. Suppose I want your a plus b to the power 0, you know that this will be your 1. And 0 we call it power or index. Similarly, a plus b to the power 1 is equal to a plus b. A plus b square. How to write this? This is a square plus 2ab plus b square. Similarly, a plus b whole cube, I hope you know. So a cube plus 3a square b plus 3ab square plus b cube. So can you say how much it will be a plus b to the power 4? Of course you can say, either you can multiply a plus b whole square into a plus b whole square, or you can multiply a plus b whole cube into a plus b. But I am writing in another way. I will try directly. Now let us learn how I am doing. I'll do directly. I will use a concept in mathematics that is called Pascal's triangle. Who was Pascal? Pascal was a French mathematician. So he designed this numbers in this way. First is your 1, then he wrote diagonally this 1, 1. Then he wrote diagonally 1, 1, and this 1 plus 1 he added to make it 2. And he found that when this power, or we say index is your 0, this coefficient of the terms is this 1. When this power is 1 here, you see it is 1. We are getting a coefficient is 1 and b coefficient is 1. Similarly, when the index is 2, he is getting coefficients 1, 2 and 1. So what will be for 3? For 3 it will be again 1. Last one is 1. See, 1. Here is the last one, 1. So how much is this? 1 plus 2, that will be 3. Then 2 plus 1, that is also 3. So see, that's coefficient a, 1, then 3, then 3, then 1. Now see another pattern. What is it? It is about a and b. Here the a has the power 1, b has also power 1. For here, first term has the power square, and in the second, a has reduced to power is reduced to 1 and b is added. In the second, a is reduced to 0, b square, a is 0. Same thing happens here. A first is a3. For the second case, the power is reduced to, then power is reduced to 1, and reduced to power is reduced to 0. That means there is no a. And what about b? B previously it was 0. Now it is increased. 1 again increased. 2 again increased. 3. So observing this pattern, I can write. Can I write? Yes, I can write. So what will be? So next we'll find another new, another new concept. What is it? When n was, this means power I'm taking as n now, it was 0, then it was 1 only. When it was 1, it was the coefficients are, I'm talking about the coefficients. 1, 1, and the power was 2, or index was 2, it was 1, 2 and 1. When it was 3, it will be 1, 3, 3, 1. When it is 4, it will be 1, 4, 6, 4, and then a 1. Now, if you will notice it, this is your. Now, my question is, what will be if it will be n? How much will be the things? So when it is 0, this will be 0 combination 0. When it is 1, it will be 1 combination 0, 1 combination 1. When it is 2, it will be 1 combination 0, 2 combination 0, 2 combination 1, and 2 combination 2. When it is 3, it is 3 combination 0. You know that n combination 0 is 1, and n combination n is also 1. So it will be 3 combination 0, 3 combination 1, 3 combination 2, and 3 combination 3. So when it is 4, it will be 4C0, 4C1, 4C2, 4C3, and 4C4. So observing this pattern, we can write the binomial theorem now. How is it? If I'll expand a plus b raised to the power n is equal to, this will be how much? This will be your, first is n combination 0, a power n, and b will be, there will be no b means 0. Next will be n combination 1, a 1 power or index is decreased and 1 power is increased, 1. Next is NC2, a n minus 2, b becomes 2. NC3, a becomes n minus 3, b becomes 3. So there will be different terms according to the value of n. So last will be, I'm writing the last but one, then I'll go for last one. N minus 1, a 1, b n minus 1. And what will the last? It will be nc n a 0 b to the power n. So this is your binomial theorem. This is your binomial theorem. So let me write again. This is a plus b to the power n is equal to nc0 a n plus nc1 a n minus 1 b to the b1 nc2 a n minus 2 b square nc3 a n minus 3 b square b3, so on. Last will be ncn a to the power 0 b to the power n. So similarly, if I want now a minus b to the power n, how to expand it? This is same as your, I'll write a plus minus b to the power n. So in place of b, I'll put minus b. So where will be changed? It will be nc0 a n plus nc1 a to the power n minus 1 into minus b plus nc2 a to the power n minus 2 minus b square, so on. And here plus ncn a to the power 0 into minus b to the power n. Now depending on the value of n, it will be nc0 a to the power n. Here it will be minus, because one time I'm in multiplying minus, so it will be b, and this will be positive because minus b square. So it will be nc2 a n minus 2 b square. Then what will the fourth term? It will be again negative. It will be again negative because now I'm taking the b is minus. So b to the power minus b to the power 3 is again it will be negative. So nc3 a n minus 3 b to the power 3. So what will the last one? Last one will be depending on your value of n. It will be n a to the power 0 and b to the power n. So let us go for some example. Now I'll write x plus 2y to the power your 3. How much will be answer? Not 3, I'm taking 4. What will be the answer? It will be 4c0, yes, x to the power 4 into 2y to the power 0. When anything to the power 0, you may write, you may not write. 4c1, x to the power 3, 1 power will be decreased and 2y will become 1. Next is 4c2, x power 2, 2y power 2. 4c3, x power 1, 2y power 3. Last is 4c4, x0, so I am not writing 2y to the power 4. So let us simplify. 4c0 is 1. I had already written. nc0 is 1. You can note down for calculation easily. nc1 is n. nc and minus 1 is also n. And nc n is your 1. So 4c0 is 1 and last 4c4 is also 1. So it will be x to the power 4 only. Next 4c1 is 4, x cube into 2y. Next 4 to c2 is 6, x square into 4y square plus 4c3 is again 4, x into 8y cube. 4c4 is 1, so it will be 2 cube 4, 16 y to the power 4. So what answer you are getting? You are getting x to the power 4, 8, x cube y, 24, x square y square plus 32 xy cube plus 16 y to the power 4. So next we'll go for some exercise questions. First question is, I have taken question 5, x plus 1 by x to the power 6. So n is 6 here. So I'll write what? I'll write 6c0 x to the power 6 plus 6c1 x to the power 5 into 1 by x. In place of y, it is 1 by x plus 6c2 x to the power 4, another power decreases, and 1 by x square. 1 by x whole square is same as 1 by x square plus 6c3 x to the power 3 into 1 by x to the power 3 plus 6c4 x power 2 into 1 by x to the power 4 plus 6c5 x into 1 by x to the power 5 plus 6c6 into x0. I'm not writing x to the power 6. So let us simplify. 6c0 is 1. 6c6 is also 1. 6c1 is 6. 6c5 is also 6. Only you have to find 6c2. 6c2 is 6 factorial by 2 factorial into 4 factorial. If we cancel 5 into 6, it will be 15. And you please note that 6c2 is same as 6c4. Why? The NCR is same as NC and minus R. So 2 and 4 makes you 6. So 6c2 is same as 6c4. So we can get 6c4 is 15, 6c2 is 15. Only 6c3, 6 factorial by 3 factorial into 3 factorial. So 3 factorial cancel, it will be 4 into 5 into 6. And 6 factorial is same as 3, 6 is same as 3 factorial, so it will be 20. So get the answer now. X to the power 6 plus, here it will be 6 into x to the power 5 into by x. It will be x to the power 4 plus 6 is 2. It will be 15. It will be x square plus 20. There will be no x because x cube, x cube will be cancelled. Then again 15, 1 by x square, or you will write 15 by x square. Next is 6c5 is equal to 6. So 6 by x to the power 4. And last is 1 by x to the power 6. So this is the answer of this question. Question number 8. Question number 8 is 100 to the power 4. See what is the use of binomial theorem. Binomial theorem, if you want to do this question, you have to multiply 101 into 101 into 101 into 101. It will take a lot of times. So let us apply the binomial theorem. Let us see whether we can get it quickly or not. So what I'll write 100 plus 1. We have to make into binomial. 101 plus to the power 4. So it will be 4c0, 100 to the power 4 plus 4c1, 100 to the power 3 into 1. No need of writing 1. 4c2, 100 to the power 2, 4c3, 100. I'm not writing power 1 because 1 is anything is 1. So 4c4. Sorry, this is plus. So what will the answer? 4c0 is 1 because nc0 is 1. So it will be 100. How many zeros? It will be 8 zeros. Plus 4c1 is 4. 4c1 is 4. So this will be 4. How many zeros? 6 zeros. Then 4c2. 4c2 is 4 factorial by 2 factorial 2 factorial. It will be 6. So 6. 4 zeros. 4c3 is 1, 4, 400. And this will be 1. Now you can add it. So how many zeros? There are 8 zeros. Next is it has 6 zeros. 4, 6, 4, 0, 0, 0, 0, 0, 0. Then 6 with 4 0. Then 400. Then 1. So what will be total? Total will be 1, 0, 4, 0, 6, 0, 4, 0, 1. So this is the answer of this question. Next is question number 11. Question number 11 is a plus b to the power 4 minus a minus b to the power 4. Find. Then evaluate. So let us apply the binomial theorem. And here you have to apply root 3 plus root 2 and root 3 minus root 2. We can put in place of ab. So first I'll write a plus b to the power 4. You have learnt it. You can learn yourself and you can check from the screen also. So this will be 4c0 a4 plus 4c1 a cube b. And once you understood, you can write directly the answer. 4c2 a square b square and 4c3 a b cube and 4c4 your b4. Now here I am writing a minus b to the power 4 just below it. So this will be 4c0 a to the power 4. Here it will be minus because 1b power will be there. So 4c1 a cube b. Next is 4c2 a square b square. And when b cube it will be again negative. And this will be positive. Now there is a subtraction in between. So then when there is a subtraction, so what you are getting? You are getting all, this term is cancelled, third is cancelled, fifth term is cancelled. So a plus b to the power 4 minus a minus b to the power 4 is equal to, there will be 2 times of second terms, 4c1 a cube b. 2 times of fifth term, 4c3 a b cube. So now I'm simplifying. 4c1 is 4 a cube b plus 4 a b cube, because 4c3 is also 4. So I can take common. So a plus b to the power 4 minus a minus b to the power 4 is equal to 8 into a cube b plus a b cube. Now in place of a, I'll put root 3. In place of b, I'll put root 2. So it will now root 3 plus 2 to the power 4 minus root 3 minus root 2 to the power 4 will be how much? 8 times root 3 to the power 3 into root 2 plus root 3 into root 2 to the power 3. Simplify. So this will be 8 into 3 root 3 root 2. This will be root 3 into 2 root 2. So it will be 8 into 3 root 6 plus 2 root 6. Or this will be 8 into 5 root 6. So it will be 40 root 6. Now just guess what will be the answer if it would be root 3 plus root 2 whole 4. Plus will be here. It's simple. Only first term will be cancelled there. If you add third will be second and third, fourth will be cancelled. First and third and fifth would be remain 2 times, 2 times, 2 times. So next time we'll go for your second exercise, general term and middle term. Thank you for watching.